Hello everyone, welcome to my channel. It's been some time that I have uploaded any videos on my channel, so this is going to be a bit different this time. Anyways, I just ran out of content ideas, so thought why not make a video out of something that I do almost every day, right? So in this video I'm going to explain you as in a recent project that I have made, and it's made using MERN stack. So not really on React, but as a front-end application, I have designed it on iOS ReactNative. So it can be also rolled out for Android as well. So it's a common base. Uh, Basically, the MERN is for Mongo, Express, React, and React Native, and then Node for backend, of course. So I'll just explain you what exactly I've done. First of all, I'll show you backend needs to be up and running first. So we'll make a new window. Okay, so this is basically my backend. I'll just fire it up. The backend is made on microservice architecture. So I'll have to start 3 different servers. One for the API gateway, one for the cart service, and one for all database transactions. Okay, so once this is up, we'll just keep it aside and go to the front end. So this is basically the front end one, and we have to start the app. So we'll just wait for the simulator to kick in and I'll show you. Alright, so this is the React Native iOS app that I've developed recently. So the front end uses React Native, of course, and lot of API integrations with the backend that's already up and running. So like you can say it's a e-commerce platform. It's a concept for not for store where customers can buy their favorite programming related t-shirts and pants, etc. So the front end is quite simple, made on React Native. This app essentially has a site banner which can be authorable, or let's say the content editors, they can author this text from the backend, and this is going to show up in your main app. We also do have a component, a CTA button enabled, a scrollable component which has the categories getting populated from the backend. These things are dynamic. For the time being, I have 2 product tiles along with 2 CTA buttons, but this needs to be implemented as well, and some free text options, and also free kind of hero images. You can consider that one. So this app has a menu, and as it's implemented in React, so I have leveraged the few states, and by which I'm tracking the states of the buttons or components, and depending upon if they're open or not, this search bar is going to get itself a dynamic component, or a dynamic functionality it has. Like you can see, this one is getting changed, and if you're going to the search option, then also the search bar is getting converted into a searchable text field, wherein you can hit in one text, and then upon searching it's just going to make a backend call, and then we're going to get the results. And also you can navigate directly to the PDP, the product description page, and in case you want to go to the home page itself, then you can just hit in the company icon here itself. And you can also navigate to the categories, let's say in web dev. Also one thing, these PLP calls, these are cached for the first time, and if you're making subsequent calls, then there won't be any kind of data change unless and until you manually go and clear the cache, the app cache. Okay, so this is example of a PLP. So all these backend products I have, I'm fetching it from the Node server, and Node server further making calls to the Mongo database, which is hosted on cloud. So a couple of items here with the item title, the price, and the ratings and the count of ratings. And here you can also see that the category name being displayed and also the number of items. Right now, if you want to navigate to a particular product, you just have to tap it, and then you get a description just like this, and also a delivery and payments page with some of the details. And then if you want to navigate back, then you can just slide it from here, just iOS thing. And also you have cart page. Now that we do not have anything in our cart, sorry for that, now that we do not have anything in our cart, so it's showing empty, but once we place an order, and it's going to get populated. Now not exactly we need to place an order, but we can just add temporarily to the cart. Like let's say if we're adding this to the bag, you also get this type of a counter which holds value specific to the products which are in your cart. Like let's say if we have two, then we can just go here, and then we can see as the price has been calculated as per the quantity, and it's displaying the same. Let's just do one thing. Let's just grab some other products and add it. We have a nice weighting GIF that I got from Google. Okay, we'll also add a couple of products from CSS. We love CSS, and maybe one HTML tag, something like that. Okay. So if your memory is quite strong, not like mine, but if it's decent enough, then this calculation should make sense to you. Okay, now we can place an order. Now this is going to get to the payment integration, and I've chosen Razorpay as a payment gateway. Excuse me. You can just type in your number, and I hope that's 10 digits. Okay, you can proceed, and for the time being we will bypass this because it's a test app, it's not a live app yet. So yeah, with test credentials you can pay, and upon success it's going to get redirected to the orders page, and then you can see the latest order, which is this one. This component is also having a functionality like if you have a lot more than 2 items, then it's going to stack the 2 items, and then the remaining items are going to get shown in this counter. Like we have 3 items, so 2 are this and 1 item is additional. This is one of the orders which I placed earlier. So yeah, so we also do have a progress bar, as in what is the status of this order. Like if you just made a payment and it's successful, then it's obviously going to be in confirmed state, and then depending upon what we receive from the backend, like the status of this order, it's going to get that much of progress. Like let's say if I'll show an example, we'll just go to Mongo. So essentially I'm storing all those order related details in Mongo. Orders. Okay, I guess this was the order which just got generated, right? So in case in future we'll be implementing a backend which updates this depending upon the inputs from the logistic partners, then maybe we can write in an API or post request or a put request which can essentially update these values so that customers are getting updated as in where their orders are, right? So let's say the logistics partner has confirmed and they have shipped, or maybe the order is already out for delivery. Then we can just update in as an out for del. That's what I've chosen the status to be. Okay, so this one is updated. We can just go back to our app and we'll just make a refresh. Now you can see, right, the progress bar is on out for delivery. So that's how these values are getting populated, and once also you click on it, you're now able to view the total amount and what exactly is the order status, I also do need to change this one for human readable. This is not something significant in this case, so we can just change this to your order is now out for delivery, something like that. And the date you place this order in, and the Razorpay order ID and the payment ID is also showing up here, and you can just copy this in case you want to raise a dispute or something like that in future. So that's also available here. I'll just go back, and so this was pretty much about the React Native iOS app. It has search functionalities. You can add to bag, you can add to cart. That's essentially the same thing. You do have category CTA buttons, you have PLP, you have PTPs, so almost everything that a basic e-commerce app should have, right? Okay, so now let's talk a bit about the backend. So essentially I followed the microservice architecture here. Okay, so essentially this is the backend code. No worries, I'll also drop the front end and the backend repo links, which you can refer to at a later point of time. But yes, so essentially I'm using Node as you're quite familiar, as in if you are aware of JavaScript, then I think the best backend server framework is Node, right? I have basically three JS files which acts as three different services. The first one, the app.js, which is the entry point, right? So whenever you're designing any kind of service or software, you're just not going to give the client different kind of port numbers or IP addresses which they can access different routes. So essentially you're just going to give them a single port or a single host name, and then depending upon what a different type of routes you have in your microservices, that specific URL it's going to redirect to a different microservice running on a different port. So you have to configure these kind of settings. So as you can see, let's say we're running in local at 5050 port, and any kind of user is hitting on 5050, like let's say 404 store 404.com, it's running at 5050 port. Okay, but we have two different files as well. One is also cart, one is db routes. So the app.js is essentially designed as a API gateway. So I have not implemented as an rate limiting and other advanced concept in this. This can be done in a later point of time, but for the time being, I'll just explain you as in what app.js is essentially doing. So we've just imported Express middleware, and we're also using .env modules or .env library to pick up certain type of environment variables. So we are essentially forwarding the requests which should be redirected to the db routes.js or the cart.js. So I'm storing this db service URL and cart service URLs, and this is getting fetched from the environment variables. For some reason I can't show you the environment variables file because it also has some AWS related production keys. So just let's say we are getting the 4000 localhost 4000, let's say for the time being 4000 getting stored in the database route, and cart service is running on 3000. Okay, so you can see a lot of port forwarding which is getting done by this create proxy middleware function. So in case anyone is hitting /cart, so essentially 5050 is getting redirected to this cart service which is running on 3000. So if a port is running on 5050 and someone is trying to hit /cart, then what exactly is going in the backend, as in this is getting triggered, right? This create a proxy middleware is getting triggered, which is forwarding your request from the 5050 port to the 3000 port, essentially the cart service. And it's as you can see, I have similar endpoints created for different kind of URLs. So I know there might be some better way of writing it, but I just find it a bit easy and maintainable and readable. So yep. Okay, one thing also you can notice before any controller is getting hit, we have this one middleware, which is quite important, right? What it is doing is that it's checking if the user request is having a user ID cookie, and if there is no existing user ID cookie, then what it does is it assigns a new user ID via cookie, and then this response.cookie it sets the user ID cookie as cookie test. I mean the key and the value in the customer's browser. So essentially, we're doing it because you want to keep a temporary track of those customers, as in if they are going to. So this basically helps you in detecting, as in the if it's a new user, and if they have added anything to the bag. So when they're adding anything to the bag, so those data it gets stored against this user ID. So that's the idea. One downside to this can be whenever we are taking a restart of this cart.js, then essentially we are just going to lose all those customer data. So that's one downside. So best practice would be to store these kind of things in the database itself, so that you do have it handy. You do not lose your cart inputs. All right. So as you can see, I'm using a couple of backend modules for server-side rendering. For for EJS, I'm using EJS as a view engine for product pages, and some of the components as well. So this is with the web app. It's not related to it. It has nothing to do with the React Native app. And also I'm serving a couple of script and style files statically using the Express middleware. Okay, and as you can see, these are all for routing purposes only. Okay, now coming to the PDP call. Okay, so this is not for the PDP, but it actually returns the EJS instance and then rendering the product in the in the front end. So we can just skip it. Check cookie, no need. Index, yep, it's again a part of EJS renderer. This is something related to the backend, which I've implemented, as in you can edit a lot of things. You can you can using this authentication. This is just a basic authentication that I'm using. You can use it to access the admin portal. I'll also show you that one. So moving to the database routes. So this service it's related to every database writes or reads. So whenever we're hitting the database, we're not directly hitting it, but we're doing it through this database routes.js service. I earlier used to have AWS setup. I'm storing a lot of image files related to the product listing and the product description page in the AWS S3 bucket. So I had to use this AWS SDK as a part of this service as well. Let's just assume that it's running at port 4000, and we're using a lot of other node libraries to get our things done, using Mongo, of course, and also introduce a database pointer, as in if you want to scale your project and if you want to introduce this whole project as a framework, then this database pointer is quite essential, as in if you if you want to exactly run these operations on a specific data set. Let's say I have two databases, one for 404 store and one for ecom, and I want to test all this transaction on the 404 store. So this database name will be 404 store. This will be a string, and once it's 404 store, then the further operations can be done depending upon these values. As you can see, so whenever you're hitting like slash products, so this is a way and point to fetch all those products, the list of products, right? So what exactly it is doing? it's creating a new client, a Mongo client, and then there's a async function which is running. So it's getting connected to the database using the credentials, and it goes to the collection name products, and then it's fetching all these products using find an empty array, and then it's converting it to an array, and then it's sending these products via response. Okay, so in case we want to see as in what exactly I mean by that, we'll just go to localhost 5050 products. Didn't work. Okay, so I haven't actually forwarded this port, I believe. Okay, product is also available. Okay, this is essentially a server call, that's why it's showing up, but in case you want to, okay, product/2 is working, but not all products are working. That is because maybe I haven't just added this route to forward itself to a 4001, which is our database. That's the reason. Okay, we can take a note of that and we can do that. For the timing, yeah, so this is how the list should look, the backend list, right? So these are all products, right? Which is basically this one. As you can see, six products, right? And we do have 6 of them, right? What else do we need to cover? Yep. So just like that, we can also categorize products depending upon their category. We can extract the active categories, right? Like web dev, MLAI. So these are all the categories. Alright, so this is also search call. So essentially the search term that we're passing into the URL, it's going to make a database search on that term, and then depending upon the algo that has been used, it's going to return. For the time being, it's quite simple. It's just making a search on the product title, the product description, product ratings. Maybe we can add in a later point of time. Yep. And then we do have couple of post requests wherein you can add products, you can add a category. If you want to build a new category, let's say we want to build something like first I'll show you as in what I'm talking about. First you need to go to admin panel. So this is something which only the brand authors are supposed to have access to, right? Alright, so if you want to add a category, let's say category name will be your Kubernetes or maybe cloud, right? We can just give in a small name like that. Okay, so cloud tech, maybe we can just call it that. If you want to keep it inactive, then you can just if you want to keep it inactive for the time being, so you can just build this category and then later maybe change the status to active. For the timing, we'll just keep it active, submit it. Okay, once it's in success stage, then if you will go ahead and refresh this app, so it's going to fetch this one, cloud tech, right? And for this sale keywords, so essentially I'm grabbing the string value first, so in case it mentions sale, then it's just going to change its color to red. That's how the conditional stylings are written. Okay, Now if you want to add a product, you can also do that, but we'll just skip it. I'll just show you as in, if you are going to add a product, then you can see as in we are also making a new call to the category active categories API, and then you can see as in what kind of category you want to choose that product that you are adding to, right? What category you want to associate that product with. And once you submit, this data is going to get saved to the MongoDB, and then you can fetch those products from there. Add products, site banner, site banner. So I'll just give you an example as in, you're an admin panel, right? That's fine. So we have an active what do we call it, site banner. So this is a bit different than the one which you see in the native app. As you can see, these are quite different. So I haven't implemented this one, like this is not dynamic, this is static for the time being, but we can implement it in something similar to this one. So this is dynamic, as in if you want to edit this site banner, right? If you have a sale coming up, let's say if you have Black Friday in a couple of days, then you can just go to site banner and you can see the active site banner is getting fetched from the database. Let's say we want to say the customers that Black Friday sale is here, something like that, right? And then status. So we want the customers to show it in our website. Just make a refresh and then you have this value here, right? This also, like the native app, it's also having what do we call it, categories. And so essentially this web app and the React Native app, they're sharing the same backend, same database, same backend. Although I'm yet to implement the payment integration in this web app, but it's already done in this React Native app, so that's fine. This also has search functionalities. You can just search and then you get it. And also one thing to note, as in these are all SEO friendly, right? So the product name are not something like this is like product /4. You also get this names in the URL, so that every time the Google bots, they're crawling and making your website more SEO friendly. So that's the main idea of naming these URLs rather than using any kind of non-human readable URLs. So also this PDP, they are all server-side rendered. That means they are also again SEO friendly. You get the content processed at the server level first before it puts to the front end. If you just go ahead and inspect, then you can see not inspect. If you just go ahead and view the page source, then you can see a lot of product details embedded in the page itself, and there's no interference of any kind of front-end frameworks or front-end JS, which is placing all this data. It's already built in the HTML source. So in that way, it's also SEO friendly. Okay, we'll close it. Again, you can add to the cart, and you also get a mini cart like this. There can be major design changes done to this one. It looks a bit ugly, but it just gets the work done. We'll just go to the cart page, and again it's going to fetch these products. $4.99. There's some standard standard delivery, and then this says register, but we can change it to pay and then integrate with the Razorpay checkout, and we're then good to go. Yep. I think I've explained almost everything about this project. Let me check if we have anything else to discuss. Maybe side banner. This is to get the side banner. Then this is to update or edit the side banner from the backend. Save order. So this I've written explicitly for the mobile app. Essentially, after the order is created, we're saving this into the database. It's not during the payment initiation. For the payment initiation, I've written it in, I think I guess I wrote it in cart. This one is the endpoint which is getting triggered whenever we're hitting on the pay button. So a create order is getting called from the front end. So we get the amount from the query, right? We get the amount along with this endpoint, and we decide the data. As of now, had coded the INR and then the amount, as advised by there is a payment gateway. We're converting it into like we're adding 2 zeros. So if you have amount of 300, then it's essentially 300 and then 2 zeros, so 5 zeros. Okay, so we do have defined configuration for which we are going to method is post, and then we are going to call the RazorPay API. Along with that, we are going to push this data. Okay, so I'm making an Axios request, and then once the once the order is created, not the order, but once the what do we call it, the payment is initiated. So this is basically done because we need to call the server, the RazorPay server 2 times. One is when you are initiating the payment. So the first call is to this API, which returns a order ID, or let's order ID and a payment ID. RazorPay order ID, RazorPay payment ID, and again you need to pass that RazorPay payment ID in your front end to the RazorPay API itself, so that they can cross verify and check if the amount is correct at every instance, and then depending upon that the rest of the flow is decided. In headers, we are just making a basic authorization, token based authorization, and I think that's it. And once the save order, once the order is created, we also need to make sure that we're flushing the cart, so that that user ID has nothing in the cart, right? I haven't implemented, as in you can specifically check out with some items and you can keep the rest of the items to be flushed later. That can be implemented, but yeah, for the time being, I've chosen not to do that. So flush cart is essentially removing your so this user is basically a user ID which you are getting, right, from the requests. So user ID, you receive the user ID and user cards. So user cards is basically one long list of array which holds the user IDs, right? So this will temporarily store the product ID and the count against the user ID till the server restarts or crashes. Yep. So as already mentioned, it's not the best idea to do it. You're going to lose the product counts, the product ID and the product counts against the user ID. So best to save it in database, right? Again, /cart is for retrieving all those cart values, flush. Yeah, and DB routes, I've already explained you these all endpoints, right? All right, so I think we're done with almost everything. I've explained you the architecture, I've explained you what tech has been used to build this project. I'll also drop in the GitHub link so that you can check it out. In case you find this video to be a bit helpful, and if you want me to discuss anything specific, any topic specifically, then maybe I can also make another video on the same. And yeah, I think we're good to close this recording, and yeah, I'll see you in the next one, and take care. Bye bye.